Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from log z equal to a log x plus square root of 1 plus minus a square log y plus b. So we are given an equation which contains arbitrary constants a and b, and we are asked to eliminate a and b and form the partial differential equation from the given equation. We are given log z equal to a log x plus square root of 1 minus a square into log y plus b, considered as equation number 1. So we will see the detailed process firstly, and later we'll go for the shortcut, that is by decreasing the number of steps. Let's partially differentiate 1 with respect to x. Apply dou by dou x on both sides of 1. Partial derivative of log z with respect to x is 1 by z into dou z by dou x equal to a into dou by dou x of log x, since a is constant, plus constant 1 minus a square into log y is also constant, since we are partially differentiating with respect to x. So we can just write this as dou by dou x of first term plus dou by dou x of second term plus dou by dou x of last term. Okay, this gives us 1 by z into, since we have a notation dou z by dou x equal to p, let's replace it by p. You'll get 1 by z into p equal to a into dou by dou x of log x plus partial derivative of constant with respect to x is 0 plus partial derivative of constant with respect to x is 0. Since we are partially differentiating with respect to x, so y will be treated as constant. Okay, so you'll get partial derivative of a constant with respect to x 0. This gives us p by z equal to a into partial derivative of log x with respect to x is 1 by x, which gives us p by z equal to a by x, or just bring this x to LHS, we'll get px by z equal to a, or a equal to px by z, considered as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating one with respect to y. Apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant, and z is a function of x and y, or z is a dependent variable, we can say. Partial derivative of log z with respect to y is 1 by z into dou z by dou y equal to dou by dou y of first term plus dou by dou y of second term plus dou by dou y of last term. Since we have a notation dou z by dou y equal to q, Let's replace it by q. You'll get 1 by z into q equal to, since we are partially differentiating with respect to y, so x will be treated as constant and partial derivative of a constant with respect to y is 0, plus constant 1 minus a square into partial derivative of log y, plus partial derivative of a constant with respect to y is 0, which gives us q by z equal to, since 1 by z into q is q by z, equal to square root of 1 minus a square into partial derivative of log y with respect to y is 1 by y. Okay. Now take this y to LHS, or bring this y to LHS, we'll get qy by z equal to square root of 1 minus a square. Now by squaring on both sides, we need to find a from this, okay, because we can find a. Squaring on both sides, since we know that square root of a can be written as a power 1 by 2, so we'll write square root of 1 minus a square as 1 minus a square for 1 by 2 raised to the power 2. We know that a power m whole power n equal to a power m into n, so we can write this as 1 minus a power 1 by 2 into 2. Where 2 gets cancelled, and this gives us q square y square by z square equal to 1 minus a square. Now we have q square y square by z square equal to 1 minus a square. Okay. Now let's bring this a square to LHS and take this term to RHS. We'll get a square equal to 1 minus q square y square by z square. Now take square root on both sides of the equation, or simply a equal to square root of 1 minus q square y square by z square simply. Okay, consider it as equation 3. Now observe 1, 2 and 3. See, 2 and 3 gives a equal to px by z and a equal to square root of 1 minus q square y square by z square, right? So you can replace this q by any of these two, but by replacing any of these two, this b, arbitrary constant b, won't get eliminated from 1. So what we'll do is we'll just equate 2 and 3. From 2 and 3, px by z equal to square root of 1 minus q square y square by z square. Then px by z equal to square root of z square minus q square y square by z square. Again we can split this square root as square root of z square minus q square y square by square root of z square. Square root of z square is z. See, since we know that square root of a can be written as a power 1 by 2, so you can write this square root as power 1 by 2. This is of a power m whole power n form, which is a power m into n. You'll get z power 2 into 1 by 2, which gives you z. Right? Now this becomes px by z equal to square root of z square minus q square y square by z. These z's gets cancelled and you'll get px equal to z square minus q square y square, or by squaring on both sides we'll get qy, or here we having px equal to square root of z square minus q square y square, right? Again we'll square on both sides, so that you'll get p square x square equal to z square minus q square y square. Okay. See, square root of z square minus q square y square whole square can be written as, since square root of a can be written as a power 1 by 2 using this, so we'll write it as z square minus q square y square power 1 by 2 raised to the power this 2, and a power m whole power n can be written as a power m into n, so you'll write it as z square minus q square y square power 1 by 2 into 2, where 2 gets cancelled and you'll get z square minus q square y square, which I wrote here. Now bring this term to LHS, take this p square x square to RHS, you'll get q square y square equal to z square minus q square x square. Okay, now we can write this as qy whole square equal to z square minus p square x square, which gives us qy equal to square root of z square minus p square x square. Simply take square root on both sides of the equation otherwise. Okay, therefore px equal to square root of z square minus q square y square, or qy equal to square root of z square p square x square is the required PD, since it does not involve any arbitrary constants, and also the equations of the form say sum f of x, y, z, p, q equal to 0 form. Okay, now let's see how to find partial derivative of 1 with respect to x and with respect to y. Simply this completes the problem. Okay, we have completed the problem. Now we'll just see the shortcut of finding the partial differential equation of 1 with respect to x and y. Partially differentiating 1 with respect to y. With respect to x, right? So derivative of log z with partial derivative of log z with respect to x is 1 by z into dou z by dou x equal to a into partial derivative of log x with respect to x is 1 by x plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0. Since dou z by dou x equal to p, so you'll get 1 by z into, just replace it by p, you'll get into p equal to a into 1 by x, which gives us, now take or bring this x to LHS, you'll get px by z equal to a. Consider as equation 2, right? Now partially differentiating 1 with respect to y. Partial derivative of log z with respect to y is 1 by z into dou z by dou y equal to partial derivative of a constant with respect to y is 0 plus constant into partial derivative of log y with respect to y is 1 by y plus partial derivative of a constant with respect to y is 0. Since dou z by dou y equal to q, so we'll replace it by q, we'll get 1 by z into q equal to square root of 1 minus a square into 1 by y, which gives us, now bring this y to LHS, we'll get yq by z equal to square root of 1 minus a square. Okay, now by squaring on both sides of this, we'll get a equal to square root of 1 minus q square y square by z square. We'll see that also. Y square q square by z square equal to 1 minus a square. Now bring this a square to LHS, take this term to RHS, then you'll get a square equal to 1 minus y square q square by z square. From this you'll get a equal to square root of 1 minus y square z square by, sorry, it's q square, right? Y square q square by z square, which is our equation 3. Now we'll equate 2 and 3, because By substituting 2 or 3 in 1, only A gets eliminated, but the arbitrary constant B remains the same. So we won't substitute 2 or 3 in 1, we'll just equate 2 and 3. Px by z equal to square root of 1 minus q square y square by z square. Squaring on both sides gives p square x square by z square equal to 1 minus q square y square by z square, or p square x square by z square equal to z square minus q square y square by z square. Okay, where z square gets cancelled and you'll get p square x square equal to z square minus q square y square, or we can write p square x square as px whole square equal to RHS remains the same, and you can write this as px equal to z square, square root of q square y square, or bring this term to LHS and take this p square x square to RHS, you'll get q square y square equal to z square minus p square x square. Now write q square y square as qy whole square equal to z square minus p square x square, which gives us qy equal to square root of z square minus p square x square. Right? This or this will be the required partial differential equation, which completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.